Okay, we're reviewing for your final exam. These chapters 4 and 5 will be on your second part of your final exam. Your final exam is during class time. First part in one class, second part in the next class. And so second part will be on chapters 4, 5, 7, and 8. Okay, so 4 and 5, chapter 4 is area measurements. Chapter 5 is volume, capacity, mass, temperature, that kind of thing. So first one, the formula that should be used to calculate the area of the shape shown below, well, to the right here, is what? Well, that is a semicircle. So area of a circle is pi r squared, and that will be on that's on the last page of your, I think it's on the last page. We'll give it to you on your test. But in your workbook for right now, let's just look at, oh, you know what? I didn't copy those formulas. Oops, let's just get that back up again. But I may have them at the end here. So metric, imperial, and then, yeah, so these are going to be, so in your workbook, there's the area of a circle, pi times r squared, and then we'll give you some extra ones as well on your final exam. Okay, so semicircle then is half of that. So semicircle will be a half pi r squared, or you could show it as pi r squared divided by 2. That's the same. All right, next one, it says determine the surface area of the lateral sides of the pyramid shown. So that means not the base. So not the base. So that means all of these triangles. So take a look at it. Remember the dashes means that all of those lengths are the same. So they're all 15. Okay. So if we take a look at this triangle on the side here, okay, this is going to be 15. And the height of that triangle is given. It's 18. It's not the height of the pyramid, it's the height of the triangle. And remember, for surface area, we want the surfaces. So we want this surface here. So if I redraw that triangle, this is 15. This meets at 90 degrees, and that is 18. So we don't need the 10 at all for this. Okay, so the lateral sides, so area of a triangle is base times height divided by 2, or 1/2 base times height. Okay, so 1/2, 1 divided by 2 times 15 times 18 is 135. We're not done yet because we need all of them. And so that base is a pentagon. 1, 2, 3, 4, 5 sides. So there's 5 of these faces. So the area of the lateral sides is 5 times the area of each of them because they're all the same. So in your calculator, you can just go times 5. And 675. And that's going to be in meters squared. All right, next one, determine the surface area of a cube that has sides of 8 centimeters. So think about a cube. All the sides are squares. Okay, so close enough. It's not quite perfect, but all of these sides are 8. So if we think about surface area, we want to find the area of one of the sides, and in a cube, there's 6 of them. So the area of one side, so not plural, is 8 times 8, which is 64. So the surface area will be 6 of those, 6 times 64. Because there's 6 sides in a cube. So think about a dice. When a normal dice for a normal board game is 6 sides, it has on it labeled with 1, 2, 3, 4, 5, 6. So that's where the 6 sides come in, or an example of that. Okay, so 6 times 64 is 384 centimeters squared. Next one, area of the shaded region to the nearest tenth. So we want the area of the triangle, and then we're taking out the circle. Because this shape here, I don't know what the area is. You actually would need calculus to solve that. So in this case, we want, it's easiest to find the area of the triangle. So area of the shaded will be area of the triangle minus the area of the circle. Okay, so area of the triangle is 1/2 the base. So we want to look, it's a 90-degree triangle. So the base and the height are actually the edges of it. So 16 times, here we don't know what that is though. Okay, so we actually have to do a little bit of work. So we have learned about the Pythagorean theorem. And so to get a leg, so I'm going to call this x. So I'm going to do this up here. So x squared is equal to the hypotenuse squared minus the other leg squared. So 20 squared minus 16 squared is 144. And then we square root that, which is 12. Okay, so that's going to be times 12. And then we subtract the area of the circle, which is pi times the radius squared. This is the diameter. The radius will be half of that, which is 3. Okay, so 1 divided by 2 times 16 times 12. You could also do 0.5 is the same as a half. You could just put that in. So that's 96. Then pi times 3 squared, which is 9. So you could do that in your head. 28.274. Yeah, 28.274. I'll go to a few decimal places and then round it at the end. So now 96 minus that answer is 67.7 centimeters squared. Okay, next part, converting temperature. So 80 degrees Fahrenheit into Celsius. So we want a formula that C equals. So if you look in the back of your book, at the bottom of the page, there are these formulas here. So we want the C equals, that's 5/9 times, in brackets, F minus 32. So 5/9, oh, sorry, that was, here, 5/9 F minus 32, where F is the temperature in Fahrenheit. Okay, so you can go 80, you could do this in a graphing calculator, you could do this all in one step. But if you don't have one, then maybe you want to do the in steps, and you would do brackets first, so that would be 48. And then, kind of taking up too much space here. If you have 48 in your calculator, multiply by 5, divide by 9, and that's 26.6 repeating. Nearest tenth would be 26.7 degrees Celsius. Okay. Then going from 25 degrees Celsius into Fahrenheit. So you can kind of tell that's slightly less than the last question. So our answer for Fahrenheit should be slightly less than 80. So Fahrenheit equals, again, look at your back of the book. Fahrenheit equals 9/5 times Celsius plus 32. No brackets. So 9/5 times Celsius plus 32. So in this case, 9/5 times 25 plus 32. So 9/5, 9 divided by 5 times 25, okay, is 45, plus 32 is 77. And that's degrees Fahrenheit, which is slightly less, as we said. Okay, next conversion is pounds into kilograms. So 20 pounds, so that's imperial, into metric. So in the back of your book, we want to go from imperial to metric, okay? But this now is a mass measurement, okay? So pounds to kilograms, 0.45. Oh, I keep doing that, sorry, 0.45. Okay, so we want to take 20 pounds, multiply 0.45 kilograms per pound. Okay, and then 20 times 0.45 is 9. So 9 kilograms. Okay. Next one, tons into pounds. So notice the spelling when it has the two N's, ES, this is metric, okay, into pounds. So metric tons. So again, we're going to go from now metric into imperial. That's the next column. So here, metric ton, so it doesn't go directly into pounds, but it does go into imperial tons. Or we could convert back in the metric column. We are told that 1 ton is 1,000 kilograms. So then we could convert from kilograms to pounds. That would probably be easier because multiplying by 1,000 is pretty easy. So I'm going to multiply. So I'm going to multiply by 1,000. So this is going to be equal to 4,400 kilograms. Now, I want to look for kilograms to pounds. So metric to imperial, kilograms to pounds, 2.21. So I'm going to multiply by 2.21 pounds per kilogram. So 4,400 times 2.21 is 9,724. No need to go to tenths for this calculation. If you had converted to imperial tons and then into pounds, then maybe there would be a decimal. It would be a value that's pretty close. We'll check for both of them. Calculate the volume of the box. So remember, this is a prism, so volume is length times width times height. So 10 times 6 times 8. Try to do that in your head. That's 10 times 48, which is 480. And this will be cubic feet. And then convert that to cubic yards. So 480 cubic feet equals how many cubic yards? So get your chart out here. This is a capacity, and this is all in imperial. So, sorry, it's a volume, not capacity. So cubic yards equals 27 cubic feet. Oh, sorry, we're going from cubic feet to cubic yards. Right, so we have to then, so 1 cubic yard equals 27 cubic feet. It doesn't give the conversion the other way, so that means we're going to need to divide by 27 here. Because a cubic yard is bigger than a cubic foot, so our numbers have to be smaller. So 480 divided by 27 is 17.8. Now you could have gone back to each dimension here and converted these into yards. So like for example, this would be 2 yards. This would be 3.3 repeating. This would be 2.6 repeating. And let's multiply that. So 2.6 repeating times times 3.3 repeating times 2 is the same. Okay? And then express the volume in meters cubed to the nearest tenth. So when I'm going to do this one, I'm going to look for my conversions, see if there's from cubic feet or cubic yards to cubic meters. Probably it's going to be yards to meters, but let's just see here. So I'm going from imperial to metric, and I've got cubic feet to cubic centimeters. I want to go to meters. So I've got cubic yards to cubic meters. So I'm going to use that, 0.76. Now, when I do that, though, I'm going to show the repeating. So cubic yards, multiply, forgot it, so I got to check again, 0.76. Meters cubed for cubic yards. And so in my calculator, I can take that last answer and multiply by 0.76, and I get 13.5 meters cubed. Okay, and that's it for this review.